Next up is John Pham, another local favorite. John works for Vercel, is going to be speaking with us about building a multiplayer experience. Fun facts about John. He chose to sleep in a hammock through college because he was too cheap to buy a mattress. John is pretty awesome. I once advised him, don't get into design, stay in engineering. He completely ignored me. And, well, you'll see what happens next. Take it away, John.
Hello, everyone. So, first step for y'all is here's a QR code. And if the QR code does not work for you, there's also the link below. This talk comes with an application, so I would like all of you to use the application as I give this presentation. I'll give y'all a couple more secs. Okay, cool. So this talk is about building a multiplayer experience. As you can see, whoever is connected to the app, like every time you click on a button, these emojis appear onto the screen. We're going to walk through how to build something like this. Yeah, I'm John. I'm everywhere on the web as John Famous. You can find me there. I like to build stuff. Here's some stuff that I've built in the past. As Rachel has said, I've leaned heavily into design stuff. So a lot of this is like cool design explorations that I've done. So let's get started with the code. Today, we're going to be building a multiplayer, accessible, and resilient React component. Even though this talk is in React, all of these principles apply to any other framework that you might be using. So let's first tackle the hardest part, which is multiplayer. Multiplayer traditionally has been like a super hard thing to build. If you try to think about multiplayer applications in like the 2010s, there weren't that many. But as the technology to build multiplayer experiences has been democratized and been made a lot easier for all of us to use, there has been a surge in multiplayer applications. So today, it's easy. You don't have to worry about all these hard problems. There are companies out there such as LifeBlocks that have solved that problem for you. So let's get started with some code now. First we want to define like what reactions we want to provide for users. In this case, we are providing four emojis for people to be using. We have a fire, and now someone's scripting. Who's scripting? Please stop that. So we have four emojis. We have the fire, we have the heart, the octopus, and the mountain. Let's build a React component. Let's call it reactions. The first thing we're going to do is wrap all of our buttons inside of a side. And then we're also applying some styling to it. And then the two things that I want to point out is this role and ARIA label. We want to build this component as accessible as possible. So with the role attribute, we are telling accessive technologies to group all of these things inside of this aside, which is going to be our four buttons. We're telling accessibility tools that these four buttons are related to like a common thing. And that common thing is provided by the ARIA label. So in this case, these four buttons are going to be live stream reactions. Now, let's map over all of our reactions that we want to render, and we're going to be rendering a button. Two things we're doing is we are overriding the default like text label with the ARIA label. In this case, we're saying instead of accessibility tools saying fire emoji X, we want accessibility tools to announce to the user heart reaction instead. This is a more descriptive label, and it's more helpful for people who rely on assistive technologies. Cool. Let's see it in action now. We have four buttons rendered on the screen. These four buttons are keyboard accessible, but right now, whenever we click on them, it doesn't really do anything yet. Let's work on that next. So, as you can see here, we have a bunch of emojis being rendered onto the screen. We want to store it in state. So every time someone clicks on a button, we want to store it into state, and then from our state, we want to render that emoji onto the screen. Once we declare our state, we want to hook up the button. So here, we're basically saying every time this button is clicked, we want to store that emoji into state. Now down here, this seems like a lot of code to render the reactions onto the screen, but there's an important reason for this. That important reason is we want to make this accessible. If we were to render all of these emojis by default onto the screen, you would be spamming users who rely on tools such as screen readers. So what we're doing instead is we are building markup for people who rely on assistive technologies, and two, for people who don't rely on it. So for people who rely on screen readers, we are declaring a live region. This tells accessibility tools such as screen readers saying, hey, whatever content inside of here, this content is going to be changing. Whenever this content changes, I want you to announce to me that that content has changed. We want to control what gets announced though. By default, if we render all of the emojis, let's say there's 500 emojis onto the screen, by default, most screen readers will like announce fire emoji, fire emoji, fire emoji, fire emoji. If there's 500 emojis, that will be announced 500 times. That's not a pleasant experience, right? So instead, we basically summarize what's happening on screen to users who use screen readers. So instead of announcing 500 emojis, instead of announcing 500 times, we're going to summarize it instead. So here we're saying only announce to screen readers like 10 heart reactions instead. And then for everyone else, we actually render all of the emojis onto the screen. Now let's check it out. Cool, clicking works. Let's try our keyboard. It works too. But this isn't what we actually want to build yet, right? Like all of these emojis are staying on the screen. We want the emojis to disappear after some time. Let's work on that part next. So let's first declare how long a animation will take. For this certain use case, I figured that 200 milliseconds felt about right. There's no right answer to this. It's basically like whatever type of style or theme that you want to go for. So again, the problem we want to solve now is every time a user clicks on a button, that emoji will stay on the screen forever. We want to remove those buttons after some time has passed. For this case, we want like after 2 seconds of that emoji being on the screen, we want that emoji to disappear. So the way we do that is every 2 seconds, we want to look at a list of all of our emojis and then remove the ones that have been there for more than 2 seconds. So this is a use interval loop. This is the same thing as use our set interval in JavaScript. And we want to run this every 200 or every 2,000 milliseconds. We're saying, hey, what's the time now? And then for all of our reactions, we want to filter out the ones that are still under the 2 second mark. Since we're relying on a timestamp for each emoji now, we also want to add that property for every time we click on the button. Do you think this will work now? Hopefully. So clicking works. Oh, it disappeared. Cool. And also the keyboard works. Disappears. Awesome. OK. This is getting closer to what we want to design, but this still doesn't look quite right? We want these buttons, or we want the emojis to like float up. So let's work on that next. For this example, I'm using Tailwind for all of the styling, but this works in normal CSS as well. So in Tailwind, I want to declare a animation. So I am declaring some keyframes called travel. I want the animation to last for 2 seconds. I want the ease in and ease out like timing curve. The reason why I chose this is because I wanted the emojis to mimic a real life object. If you think of a car, whenever a car starts up, it slowly ramps up to speed, right? And then whenever it stops, it slowly ramps down. I want that emoji I want the emojis to feel just like that. This is like the animation iteration count. I only want the animation to flow through the keyframes once. And then once the keyframes are done, I want it to stay in the end position. Now let's go to the keyframes. So first, the emoji will start below the screen. This rotation I will cover later. I want the scale to start at 0, so it's super tiny. And then I want the opacity to be 0. Next at the 5% mark, I want the emoji to scale up a little bit, and then also for the emoji to appear on the screen for a little bit. And then at 40%, I want the emoji to appear at 100% and also scale up a little bit more. There's no right answer with creating these keyframes. You basically just want to figure out like what looks right to you and what feels right for you. Then to close out the keyframes, once we reach 60%, the emoji should be fully visible and then fully translated up on the page. After we've declared our animation, we now need to attach this animation onto the elements for the emojis. So going here, we're back inside of our React component that renders all of the emojis. And then we can now add on that class name, which will attach that animation onto this element. Let's try it out now. So every time we click, there's some emojis floating up. Let's try the keyboard, and that also works. So it looks like we're done, right? But there's something weird about this animation. Like it doesn't look quite right. Like every single reaction looks the same. Like it doesn't have a organic feeling to it. One way we can add some organic feeling to it is by including some randomness. So let's do that. We're back inside of our button. And the way we're going to be introducing some randomness is by adding a random timing animation curve and also a random angle. Let's see what that means. For our random animation curve, this is a custom animation timing function. We don't want every single emoji to float up in the exact same way. We want to add some variety to it. So this is some randomness with some magic numbers. There's no science behind these numbers. You basically just keep changing numbers until something feels right. And then for the angle, before every time you clicked on a button, each emoji would appear perfectly straight up. We want to introduce some variety in the angle that it's facing. So we want some emojis to be facing left, we want some emojis to be facing right, then we also want some variety in that. So some are a little bit to the left, some are really to the left, and so on. Now that we added that, we need to add it onto our emojis themselves. So we want to add it onto the emojis themselves. Okay, let's try it out now. We can click on this, and now there's some randomness now. Let's check out the keyboard, and it still works. Cool. So far we've built our component to spec, right? Every time someone clicks on a button, a animation happens. But the original point of this talk is to build a multiplayer experience. What we want to happen is every time you click on a fire emoji, you want that fire emoji to appear on someone else's screen. Not just someone else's screen, but whoever else is also tuned into the same room as you. Let's work on that part next. Since we're using live blocks for this, here's how you can add live blocks into your application. Okay, cool. So for the live blocks code, you first initialize a client. Once you have the client, you also need to wrap your application inside the room provider that live blocks gives you. Okay, now back to our application. It should work now, right? Clicking all these buttons should work. But The only thing that's changed from before to now is we've wrapped our application in live blocks. We still need to do the work of like publishing and broadcasting all of our events and also subscribing to all of the events that get published. Let's work on that next. We're back inside of our React component. Remember here, this is where we're storing all of our reactions for every time we click on the button. What we want to do here is import the useBroadcast event hook. What this hook allows us to do is broadcast any type of data to any other client that's subscribed to our room. So here's some more code for our button. Now, we want to scroll down. We're now looking at the button for each emoji. So the only code change that we want to do is add in a broadcast call here. So before, we were only adding that emoji into our local state variable, but now we also want to broadcast this out to everyone else. Let's check it out. I'm clicking. It still works, right? This thing is being broadcasted to everyone else. So whoever else is subscribed to this room should also be seeing that. We can actually check this by opening up our dev tools. We can hop over to the network tab, and then I'm going to refresh this page. Under the WebSockets tab, you should be able to see on this WebSocket connection to live blocks. So we can see that the WebSocket connection here is to live blocks. Then if we switch over to messages, every time we click on this, we can actually see what type of data that we are sending or what type of data we are broadcasting to everyone else. So this looks like it's working so far. So far, we've written the code to broadcast messages, but we haven't written the code to receive messages yet. So let's work on that part next. We're back inside of our React component, and the next thing that we want to do is declare a new state variable to store all of our remote reactions. I will explain later on why we want to differentiate from like our local reactions from our remote reactions. The next thing we want to do is use this hook provided by LiveBlocks, which is called useEventListener. And this is just like a normal JavaScript event listener. So imagine you have a button. If you add a onClick listener to it, some code will run every time you click on the button. That's the same mental model that you can have with this hook. So with this hook, every time a message is broadcasted, you will receive that message, and then you can do something with that data. In this case, every time we receive a message, we will push that message as an emoji onto our list. And then for some code cleanup, let's rename our previous list to all local reactions, so it makes it easy to differentiate from local reactions from our remote ones. OK, do you think it will work now? So we're clicking here. Hey, it's not working. Why? Yeah, we're not rendering the remote reactions yet, so let's do that part. So we're back down to where we render all of the reactions. Here is our previous code where we rendered all of our local reactions. Now we're doing the same thing for all of our remote reactions. And then we also want to update like all of our screen reader stuff. So now we're saying the total count between all of our local reactions and also the remote reactions. That's the description that we want to provide to screen readers. And then for all of the reactions that we want to render for people who don't rely on screen readers, we want to render both the local reactions and also the remote reactions. And then we also want to update our cleanup function. This is the function that cleared out all of the reactions that were older than 2 seconds. So here, we're cleaning up all of our local reactions, and then we're also cleaning up all of our remote ones. OK, should this work now? So we have client A right here. I'm clicking on this side. Then if I click octopus on this side, it still works. Let's try the keyboard, fire. Awesome. And then on this side, octopus. Awesome. Thanks. OK, so here we have 2 clients. How about 4 clients? Octopus, it's appearing on everyone. Heart, cool. Fire, it's appearing on everyone. And mountain. So this can scale up to however many clients that you want. So everyone in this room, like all these emojis that are appearing on screen, like that's all being broadcasted from all of your individual devices. That's pretty much it. So the whole reason why I went down this was at the company that I work at, it's called Vercel. We had a live stream back in May, and we wanted to introduce some interactivity to it. One of the ideas was to allow people to create live reactions during our live stream. So that's what happened. The cool thing about this was we had the idea, and then we started building it, and 2 days later, like that's when the actual conference happened. So the hardest part of this is like all of the infrastructure stuff and sockets and like scaling. Like we didn't have to deal with all of that. Like we got to focus on like the core visual aspect, which is what our users actually care about. And then since I tweeted this, like another person on Twitter named Arthur actually created his own version. And I think this version is actually way cooler than mine. Let's zoom in. So this is his version. If you can see, like there's like a shiny effect happening. And then the very cool thing is like each emoji like actually does something completely different. So let's do thumbs up. There are some balloons after it's 10 clicks. There are some hearts, and the hearts change colors every single time you click. There's a laughing one, which is like our standard animation. And then the sad one, like it actually cries. And then this is the profanity one. You'll see why. But yeah, well, thanks. That's pretty much all I had for the talk. You can see that these slides are actually like a web application. All of your reactions are being counted. You don't have to take a picture of the screen, actually. For those of you who are reacting, like that's an actual application. So I can actually send you all of the links right now. OK, cool. All of your screens should have swapped to something else. Did it work? OK, cool. Well, thanks.